How to use the Pythagorean theorem to calculate this blue area. The blue area is formed by drawing a quarter circle with radius 4. Then we remove from this quarter circle a semicircle with radius 2, and finally we remove a circle with an unknown radius. So our area will be the area of the quarter circle, which is the radius squared, which will be 16 multiplied by pi and divided by 4. So 16 pi 4 is the area of this quarter circle minus the area of the semicircle. So it will be 4x pi 2, and finally minus the area of the circumference, so I'll put here pi r square, where this r is the radius that we don't know. So first I'll take the center of this semicircle and the center of this circle, and I'll join them there, as this semicircle is tangent to this circle. This segment will pass exactly at the point of tangency. I'll draw here a segment parallel to this side with the aim of having a 90 degrees angle here. So there we have a right triangle. Note that from here to here is the same thing as from here to here, which is the radius of the circle that we call r. So this measurement is worth, and since from here to here is worth 2, from here to here is worth r. So this leg here has to be worth 2 minute r. From here to here is the radius of the semicircle, which is worth 2. From here to here is the radius of the circle, which is worth r. Now this other leg here, I will simply call it x. Then let's start applying the Pythagorean theorem to this right triangle here. Then you will have 2 minus r squared plus x squared equals 2 plus r squared. So notice that we have an equation with two unknowns. So let's look for another triangle in our figure. Let's now consider the center of the quarter circle and this point of tangency here between the quarter circle and our circle. So I will draw a segment that joins these 2 points. Then notice that this segment passes exactly through the center of the circle. Now notice that from here to here is worth, and this entire segment here is exactly the radius of the quadrant of the circle, which is equal to the side of the square, which is worth 4. So if this is all worth 4 and this little piece here is worth r, then this part here has to be worth 4 minus r. So notice that we now have another right triangle. So let's again apply the Pythagorean theorem to this other triangle, and with that we will obtain that r squared minus x squared equals 4 minus r squared. So subtracting the two equations x squared minus x squared will be equal to 0, then you will be left with 2 minus r squared minus r squared. So I will write here 2 minus r squared minus r squared. Now passing to the other side of the equality, we will be left with this minus this. That is 2 plus r squared 4r squared. So now we have an equation involving only. And then if you expand these squares here, solve the equation, you will find r equals 1. That is, the radius of this circle here is worth 1. So now that we know the value of r, we can replace the 1 here by 1 there, simplifying the resulting expression, we will find that the desired area is worth pi